Finally, what's the solution? What should we do to our plastic leftovers after the containers are empty? Let's recycle them. Now, every plastic container, if you look at the bottom, usually you see a triangle with a number in it. What we are challenged with is there are many plastic, remember they were thermosets. Once they are molded into a shape, then after that you cannot melt it down and recycle it. So you have to sort it out, chop it up into smaller pieces, and maybe just use it as a filler for other things. Then also remember that plastic that contains chlorine, we cannot burn them in order to get rid of them because they release dioxins. So those are the challenges we are faced with. Every plastic container has this sort of triangle going, indicating recycling. Then there are numbers 1 to 7. The numbers has nothing to do with how hard that plastic is or the frequency of recycling. It's just for sort of for ease of identification. So number 2, for example, is high density polyethylene. Number 3 is PVC. Number 1 is polyester, and so forth and so on. Number 7 is those that cannot be categorized into some of these. And then there are plastics that we cannot recycle because they contain bromine and other stuff. Now, recycling plastic is extremely energy intensive process. It's not like your aluminum can that was easily recycled. What we need to do is collect them, separate them, get rid of the labels, and wash the debris. Then automatically we have to sort it out using infrared or near infrared scanning. And then after that manually we have to check and make sure they've been separated. Then we ground the flakes, the plastic into flakes and reuse it. We try to reuse it. Now this is some sort of schematic for the sorting of plastic. Now just remember, 1 bottle of PVC, if you don't sort it out, will pollute about 100,000 high density polyethylene. So it's very important that we sort them out properly. Now human eye is not capable of doing that. So what we use is infrared sensors. At this stage, they will decide which is which, and then automatically it goes to separate containers. Now what infrared does is will go after the molecules, and the molecule will absorb some of this radiation, and then you usually have a chart, you have it in your data booklet, and spectrum is there, and it will indicate what sort of bonds you have. So this is spectrum of polyethylene, for example. We'll worry about the questions, what questions we are going to be asked as students later, but this is how this equipment does the separation by infrared, and automatically it will sort it into different bins to be used later on. So one bin for high density polyethylene, one for polyester, for example.